Hello friends, I am Aher from RBNB College, Rampur. Today we start the chapter Superposition of Waves. Now in this chapter we start the sonometer and uses of sonometer. Then what is sonometer? Sonometer consists of hollow wooden box having holes. These are the holes for the mass of the air is enclosed in this sonometer box. This is due to, or the sound is produced due to this air, and hence it is called as sound box. Now the metal wire is fixed at one end and it is passed over the bridges, then passed over pulley, then it is attached to the hanger. Slotted weights are attached to the wire and another end of the wire. Now the tuning fork of fixed frequency or unknown frequency, it is vibrated and kept on this sound box. Then when the frequency of tuning fork is exactly equal to natural frequency, the wire vibrates with maximum amplitude and paper rider falls. The length, it is called as vibrating length, and this vibrating length is L. Now here the fundamental frequency is given by N is equal to 1 upon twice L under root T upon M. Here N is the fundamental frequency of the tuning fork or natural frequency, and L is vibrating length, T is tension applied, M is mass per unit length. Here we use the paper rider test. The sonometer is used in two ways, that is, first to determine unknown frequency and verify the laws of vibrating string. The unknown frequency is determined by this formula, that is, natural frequency of vibration is exactly equal to frequency of tuning fork, and it is given by 1 upon twice L under root T upon M, where T is tension applied, M is mass per unit length, L is vibrating length. Now here see, substituting all the values, that is vibrating length from here, tension applied from here, and we can record the mass of 100 centimeter of mass of the wire and divide by its length. It is linear density. It is called as mass per unit length. Now the sonometer is used. There are uses of sonometer. First, it is to determine the unknown frequency of tuning fork, and second is, the first is, we use sonometer to determine unknown frequency, and second, it is used to verify the laws of vibrating string. There are main laws of vibrating string. Now the first law of vibrating string, verification of first law of vibrating string. See, by applying the suitable tension, we consider, suppose the frequency of tuning fork N1, it is vibrated by the hammer and kept on this sound box. The distance between the movable bridges are adjusted so that the frequency of the natural frequency of vibration is equal to frequency of tuning fork. Paper rider falls down. Now first we take, suppose the frequency of tuning fork N1. The tension applied is take common or is take constant. M mass per unit length is constant, tension applied is constant. Then we take the frequency, tuning fork of frequency N1, it is vibrated by the hammer kept on the sound box, and by adjusting the distance by the movable bridges, the length, vibrating length, that is when there is resonance, that is natural frequency of vibration is exactly equal to frequency of tuning fork. The paper rider falls and the distance between two movable bridges, it is L1. Now the second tuning fork of frequency N2 and corresponding length is L3. The third tuning fork frequency is N3 and length is L3. Now we consider, suppose N1, N2, N3 are the frequencies of tuning fork and corresponding lengths are L1, L2, L3. Now we take the product, that is N1, L1 is equal to N2, L2 is equal to N3, L3. It is observed that the product N1, L1 is equal to N2, L2 is equal to N3, L3, that is it is constant. Therefore, we can say that L is equal to constant. Then N is equal to constant multiply by 1 upon L. For constant and equal, we can write N is inversely proportional to L, that is fundamental frequency is inversely proportional to vibrating length. This is the first law of vibrating string. Now we can verify the second law of vibrating string, verification of second law of vibrating string. In second law or the second law of vibrating string, suppose N is the fundamental frequency and T is the tension applied. The second law of tension is fundamental frequency is directly proportional to square root of T, tension applied, where L and these M are constant. L and M are constant. Now in this case length is constant, mass per unit length is constant. Then we can take the frequency of tuning fork N1, N2, N3 are the frequency of tuning fork and corresponding tensions are T1, T2, T3. Then we find the factor N1 divided by root T1 is equal to N2 divided by root T2 is equal to N3 divided by root 3 is equal to constant. Therefore, N divided by root T is equal to constant. Thus, N is directly proportional to root T, that is fundamental frequency. Fundamental frequency is directly proportional to square root of tension applied, where L and M are constant. The length is take constant, mass per unit length is constant. We find that, we observe that N divided by root T is equal to constant. Now the third, verification of Third law of vibrating string. Vibrating string. Now in this case, the frequency of tuning fork is N1. The corresponding mass per unit length is L1. Then suppose we take length is constant, tension T is constant. Now we take the frequency of tuning fork N1, corresponding linear density is M1. The another tuning fork having frequency N2 and linear density is M2. That is, in both cases, this is the wire we take, two different wires. Then we take N1, that is frequency of tuning fork, and where length and T are constant, we can take the mass per unit length here. Now the product N1 divided by or N1 root M1 is equal to N2 root M2. It is constant. That is, we can say N root M is constant. Thus, N is inversely proportional to square root of M. Thus, we can say that fundamental frequency is inversely proportional to square root of linear density. Thank you.